Namaste everybody. I'm Lata Nettur, mathematics teacher and principal of Nettur Central School. Today, let's learn more about pair of linear equations in two variables of class 10th CBSE. You have already learned what a linear equation is. Linear equation in one variable, if you say, for example, it is 3x plus 5. And linear equation, this is called linear equation in one variable. And if you take equations like this, 2x plus 5y plus 8 is equal to 0. Here you see there is x and there is also y. Such an equation is called linear equation in two variables. Linear equation in two variables. Right? Okay. Now, when we say, let's come to what do we understand by solution for the equation. What do you mean by solution for the equation? Now, if you take one variable equation, I'll take the same example what we have taken before, is equal to 0. Now, when you solve for x, you get x is equal to minus 5 by 3. This is called solution of this equation, which means when you substitute this value in this equation, then it becomes equal to 0. LHS becomes equal to 0. If you take the second step, then LHS and RHS will be equal. So, what is the solution of an equation? Value of the variable which makes the equation value 0. This is called solution. This is solution. Okay. Now, let us take this linear equation in two variables and see what a solution means. What is solution of this two variables equation? Here, when we say solution, we are talking about pair of values. Pair of values. That means one of x value, the other one is y value. So, a pair of values, this pair which makes the value of this equation 0 is called solution of linear equation in two variables. We are talking about a pair here. Okay. Now, if you take this 2x plus 5y plus 8 equals 0, there must be some value here which will make this entire equation, entire LHS 0. Such a pair is called solution of this particular equation. So, solution in two variables means we are talking about both x and y value, which when substituted makes the polynomial 0. Value of the polynomial 0. So, what is this pair of linear equations in two variables? Means we are talking about a pair of equations in two variables. We will take two equations at a time. Okay. Along with this, if we are also talking about this equation, let us say, okay, it could be any value. Now, there must be some value. There must be some value for x and y, which when substituted in both these equations must make both the equations value 0. So, such a pair of values of x and y which make both. There could be a situation where there are many such pairs which will make both the equations 0. That means which can be applied to both the equations, or there can be only one such pair which can be substituted here and make these values of this equation 0. Or the last possibility is there could be no such pair at all which can make these polynomials value 0. So there could be 3 situations when we take a pair of linear equations in 2 variables. One is there could be just only one value, there could be infinite number of values, and there could be no values at all, no pair at all which could be this. Now let us see what these special conditions will do to these pair of linear equations. Well, you know very well, you have already studied in previous class, linear equation in 2 variables when plotted on a graph, when plotted on a Cartesian plane. What does it give us on a Cartesian plane if you plot this equation on a graph, on a Cartesian plane? It gives us a straight line, right? Straight line can mean anything. This is just an example I am giving. This, when plotted on a Cartesian plane, gives us a straight line. This can be even easily understood, better understood. If you see this word linear, you see this word line, isn't it? This itself tells us that when you plot this equation on a Cartesian plane, you get a straight line. Now, when you plot another equation on the same Cartesian plane along with this line, how does that relate to this already existing line? See, there could be 3 possibilities of its relationship with the existing line. Now, I will just draw all the 3 here and I'll tell you what it could be. Okay, fine. Let us say there is this line already, which is 2x plus 3y is equal to 5. Now, let us say we draw or we plot another equation on Cartesian plane along with this. For example, now I will just take this 2x plus 3y is equal to 5. Now, let me take another equation 3x plus 3y is equal to 6. 3x plus 3y is equal to 6. Probably this will come something like this or any other way which intersects this already existing line, which is 2x plus 3y is equal to 5. And this could be 3x plus 3y is equal to 6. Then, what is the other way of getting this second line? Probably when you draw another line. Now, let me just give an example for this equation. 2x plus 3y is equal to 5. And if you draw something like this, 4x plus 6y is equal to 7. This equation could probably come. The other possibility could be the second equation runs parallel to the already existing line. Could run parallel. So this is our first equation, which is 2x plus 3y is equal to 5. And this is our second equation, which is 4x plus 6y is equal to 7. There's another chance, another possibility of second line plotted. What kind of relationship? Probably, see now the third possibility could be the second equation just coincides the already existing line. Coincides the already existing line. So this equation, for example, if you say, let us say we are plotting this line on the same Cartesian plane. This line could be coinciding on the already existing line. So we have both the equations. One is our first equation, 2x plus 3y is equal to 5. And what is our other equation which we have plotted, which you have taken as example? 4x plus 6y is equal to 10. Yes, did you say? Now this is, in this, if you say these two lines are meeting at one point, only one point, they are intersecting at one point, and this is the point, intersection point, right? And in this situation, they are not meeting at all. They do not meet at all because they run parallel to each other. And in this, they just coincide. So, such a set or such a system of pair of linear equations is called intersecting. This is called intersecting lines. This system is called intersecting. And what is this system called? Which we have already used the word. This system is called parallel. And what about this system? Yes, this is coincident lines. What is this system? Coincident lines. So we have intersecting, parallel, coincident. Now, we have already discussed about what are solutions for pair of linear equations. In this is the case where there is only one such pair which is common to both the lines. When we say solution for pair of equations, we are talking about solutions which are common to both the lines. So, in intersecting, we have one common solution. There is only one common because it is intersecting at one place. So, if this is x and this is y, this is called unique solution. What is it called? How many solutions does it have? It has unique solution, means only one such pair which satisfies both the equations, which can be a solution for both the equations. And here, what is this now? These are parallel lines. They have to meet at a point. Since they do not meet at all, the situation is no solutions at all. In this, since they run parallel, there are no solutions at all. That means there is no such pair of values for x and y which can be common for both these two lines. And what about this? See, every point of this line is also a point on the other line. And how many points are there on this line? Infinite number of points. So what does it mean? This set will have infinite number of solutions. Means there are infinite number of pairs in this called, first we'll say infinite solutions. Means there are infinite number of pairs which are solution to both the equations. So, intersecting, unique solution means one solution. Parallel means no solutions. Coincident means infinite number of solutions. And intersecting lines, this system is said to be consistent. We call this as consistent. This is consistent. And here, which do not meet at all, is inconsistent. What kind of lines they are? They are called inconsistent lines. And what are these called? Yes, consistent, one solution. Many solutions, we get dependent, consistent. We call the lines as dependent, consistent. Yes, so what are these lines called? Consistent lines, inconsistent lines, and dependent, consistent lines which are coincident. Now let us see. Now when these are there, right, we know that linear equation in two variables can be expressed in standard form. What is the standard form? It is ax plus by plus c equals 0. This is the standard form of linear equation in two variables, ax plus by plus c. Right? If there was only one line, we call it as ax plus by plus c. But in this system where we are taking pair of equations, then we have to have some change in the standard form, in the way we call these equations. Now, one equation can be represented as a1x plus b1y plus c1. Yes, you guessed it right. So, what could be the second one? You must have already guessed what the second one could be, because here I use 1, 1, 1. So, what is the second one? a2x plus b2y plus c2. Right? So, now you know what is the standard form of expressing pair of linear equations in two variables. Standard form. Yes. We will discuss what is the standard form now. The first equation we consider is a1x plus b1y plus c1. And what about the second equation? It is a2x plus b2y plus c2. a1x plus b1y plus c1 equals 0. Remember, children, a1, a1x, b1y plus c1, all the three terms are on left hand side in the standard form. Remember this statement, because we have to keep this in mind when we are solving further problems. a2x plus b2y plus c2. Yes, this is how we represent pair of linear equations in two variables in their standard form. Now, let us try to understand how to identify whether the given pair, when plotted on Cartesian plane, gives us intersecting, parallel or coincident lines. Just by comparing the ratios of the coefficients. When I say ratio of this coefficient, what do we understand by the term ratio of the coefficient? First ratio is a1 by a2. What about the second coefficient ratio? b1 by b2. This third ratio is c1 by c2. Now we have three sets, right? We have intersecting, parallel and coincident. So I will write this 3 times so that you understand it better. A1, A2, B1, B2, C1 by C2. A1 by A2, B1 by B2, C1 by C2. Now in this, if A1 by A2 is not equal to C1 by C2, we don't even see this third ratio. We don't even have to see the third ratio. First compare A1 by A2 and B1 by B2. If they are not equal, then such a system is intersecting lines. They form intersecting lines. And intersecting lines, how many solutions? So remember, when I say solutions in pair of linear equations, we are talking about pairs which are common for both, right? So how many such common pairs are there intersecting? Only one such pair, one solution. Now, this I told you, compare. If it's not equal, don't even see this. You don't even have to worry about this. Okay? Next. A1 by A2 is equal to B1 by B2. Right? And this one is also equal. There could be two situations. Not equal. 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 Not equal. Yes? Equal, 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 not equal. Now, if all the three are equal, then such system is called coincident lines. What kind of lines do they form on Cartesian plane? Coincident lines. And how many solutions, children? We discussed already. Infinite number of solutions we get. And what about this? A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. When you compare these ratios in the given equations, you can make out. Then such a system is parallel lines. You get parallel lines. And how many solutions? No solutions. No solutions. Very important to remember this. One, infinite, no solution. What's the relationship? A1 by A2 is not equal to B1 by B2. And this is all equal, equal, not equal. With examples of equations, you will be able to understand better. I'll just give you some equations, examples. Now, let's try to understand the ratios of coefficients and the relationship with some examples. Now, let us take these two equations. 2x plus 3y is equal to 5. 4x plus 6y is equal to 10. Now, first let us change this to standard form. What is our standard form? a1x plus b1y plus c1 equals 0. Similarly, we do write for the other equation also. So now, as I told you before, all the three terms must be on left hand side. But here, this third term is on RHS, so we will transpose it to LHS and rewrite this equation. 2x plus 3y minus 5 equals 0. 4x plus 6y minus 10 equals 0. So, what is our A1? A1 is 2. B1 is 3. C1 is, remember to take it along with the sign. C1 is minus 5. Now, A2 is 4. B2 is 6. C2 is minus 10. Yes, minus 10. Now, first we will find the ratio separately and then compare. Okay. So, first we will see A1 by A2. What is it? We must bring it to the simplest form. 2 by 4. Simplest form is 1 by 2. Similarly, B1 by B2 is equal to 3 by 6. 3 by 6, which is 1 by 2 again. 1 by 2. Then, we will see C1 by C2. C1 by C2, which is minus 5 by minus 10. Minus 5 by minus 10. And both numerator and denominator are minus, it becomes positive only, which is 1 by 2. Right? So, compare the ratios now. A1 by A2, B1 by B2, C1 by C2, all are equal. All are equal. So, we'll write this as A1 by A2 is equal to B1 by B2 is equal to C1 by C2. This is what we got. What kind of system is this now? You see all these three? Yes, this is coincident system. This is an example for coincident. This is how we find. Now, I'll quickly show two more equations. Now let us take this equation. 2x plus 3y is equal to 5. 4x plus 6y is equal to 20. So we will quickly change this to standard form. 4x plus 6y minus 20 equals 0. So we'll write here only a1, b1, c1, a2, b2, c2. Remember, this is minus 5, this is minus 20. So what is a1 by a2 for us? 2 by 4, which is 1 by 2. What's b1 by b2? Quickly it is 3 by 6, which is 1 by 2. c1 by c2 is equal to minus 5 by minus 20, which is 1 by 4. So what do we understand? Here you see a1 by a2 is equal to b1 by b2. a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. Where do we get this relationship? Yes, it is parallel relationship. So when these two equations are plotted on Cartesian plane, we get lines which are parallel to each other. Now, let us see third set of equation. Let us see third set of equation. I'll do it here. X plus 3y minus 6 equals 0. 2x minus 3y minus 12 equals 0. So, let us say a1, b1, c1 minus 6 children, be careful. a2, b2 is minus 3. Again, as soon as you see minus sign, you should be very cautious. This is c2. Minus 12. Remember, it is minus 12. Now, let's see what is a1 by a2. What is a1 by a2? 1 by 2. What's b1 by b2? It is plus 3 divided by minus 3 by minus 3, which is minus 1 by 1. Just a tip, whether this minus sign comes in numerator or denominator, it just can be written with the numerator. It belongs to the entire fraction. Now, you just observe before you see C1 and C2, A1 by A2 is half, B1 by B2 is minus 1 by 1. They are not equal. As I told you before, once you find that these two are not equal, you don't even have to check C1 by C2 ratio. Right? So, you can stop at this and conclude just with this that these two set of equations, this set of equation, what kind of equation is this now? Yes, this is intersecting. This set of equations form intersecting lines on Cartesian plane. So, with this explanation, you can solve the second exercise of this particular chapter. I will show you how to plot given pair of equations on Cartesian plane. So, I have taken your exercise problem. X minus y plus 1 is equal to 0. 3x plus 2y minus 12 is equal to 0. So, let me begin. Now, I will take this equation first. X minus y plus 1 equals 0. The first step is to express one variable in terms of the other variable, which means keep only x on left hand side, transpose all the other terms to right hand side as per the basic rules. It's not necessary you have to have x only on left hand side. When you have x on left hand side and transpose all the other values, then we say x is expressed in terms of y. If you keep y on left hand side and transpose all the other values, then we say it is y expressed in terms of x. So either way you will get the same values. So now I will express x in terms of y. So y transpose to, let term by term you should do, otherwise you will get confused. Minus y, first shift that, it becomes plus y, and plus 1 becomes minus y. Now our equation is ready for substitution. First, let me take, now keep one box ready always. This is going to lessen the errors that you make when you are substituting the values. First, when y, so on right hand side whatever variable is there, that you have to assume first. When y is equal to 0, you can start from there only. Then x is equal to, see here we are taking this equation. X will be, in place of y I am writing 0 minus 1. So what is x? X is equal to minus 1. X is equal to minus 1 when y is equal to 0. One pair is ready. Now let me get the other pair. When y is equal to minus 2, let me say minus 2. Then x is, you can take any value, you can take minus 1 also. You can take plus 1 also. Okay, I will take minus 1. Okay. Then x is equal to, in place of y, you write minus 1. And whatever is there, minus 1. So what did you get? X is equal to minus 2. X is equal to minus 2 when y is equal to minus 1. Yes, our sets are ready. Now, let us get such two pairs of values for this equation also. 3x plus 2y minus 12. And right here, 3x plus 2y minus 12 equals 0. Express x in terms of y, which means we are keeping only x on one side, but one by one we have to transpose. First, transpose minus into minus, change to plus, and get the negative value here, minus 2y. This is only for easy understanding. You won't have many errors, that's it. Okay. So here again, 12 minus 2y. Now this 3 here will come to denominator. This equation is ready for substitution. Okay. So now let us have one box ready for this also. This is very, very important step that you should not miss. X. Now let us take the values. What kind of values should we assume for y? You assume such a value which leaves only the number in the numerator which is divisible by 3, so that you don't get any decimal values. So you just try to understand now, if you are just left with 12 only here, then it becomes 3 1s are 3 4s are 12. Your x will become 4. So for that we should make this as 0. 12 minus, when y is equal to 0, 12 minus 2 times 0 by 3. So what happens here? X is equal to 12 by 3, which is 4. Now when x is equal to 4, when y is equal to 0, x will be 4 when y is 0. Immediately write the values in the box. Next, you have to assume another value. When y is equal to, what other value? Now if you take y is equal to 6, right? When you take y is equal to 6, what happens? 2 2 6 are 12. 12 minus 12 will become 0. So your x will become 0. So when y is equal to 6, x is 12 minus 12. Right? You understood how we got this? 2 times 6 it is. Y is equal to 6. X is equal to 0 is another value. So x will be 0 when y is equal to 6. Now our values are ready for substitution. Let us substitute. How do we understand this? Now first let us plot this line, which is x minus y plus 1. X is equal to minus 1. Always remember the basic rule while plotting on Cartesian plane. When you want to keep a point, first always every point should begin from the origin. So I'll start here. My hand now only two options, either to go right or left. You have to have two steps. Okay, one is start from here, right or left. Based on the x value, we decide whether we go to right or to left. X is minus 1, so we should go to left. Yes, and don't keep any point here. It will be very confusing. Don't keep a point here until your y value is 0. So you don't have to go up or down. You are going to stop here only. This is your first point. Right? Immediately write the coordinates here. Minus 1, comma 0. Next, come to this. Minus 2, minus 1. Again, what did I say the rule is? Start from the origin. Minus 2. So where do we move? To left hand. Don't keep a point here. Now minus 1. So now you have to decide whether you have to go up or down. Minus 1 is here, down. Right? So where do we go? You have to take the line there. Right? Be very careful when you are drawing the line. It has to pass through this point and this point. We will move on to the next plotting. What is this? Now, again from the origin, x comma, we have to write the coordinates here, minus 2, minus 1. Then it is 4 and you don't have to go anywhere. It is here only, 0. This is because y is 0. So it is on the x-axis. When y value is 0, point will be on x-axis. When x value is 0, the point will be on y-axis. So this is our first point, which is 4, 0. 4, 0. What's the next point? Again from the origin. For every point, your hand should come back to the origin. 0. X is 0, so we don't have to go anywhere. But this is 6. Exactly here. Plus 6. So intersection point is somewhere here. What is the intersection point now? Now the question asked is, what is, see now if you notice, this is our line. We should write the equation. X minus y plus 1 is the equation, equals 0. And what is the second equation? This is our second line. Once again, I will use a different color so that you understand Okay. What is the second line now? 3x plus 2y minus 12 equals 0. This is your second line, right? Now, if you observe these two lines, this is one line and this another line. Question might be asked in two ways. Find the vertices of triangle formed by these two lines. And from here there are two different types. These two lines with x-axis, these two lines with y-axis. Now, these two lines, wherever they cut, intersect y-axis, this is one triangle. You see, intersection point will be same. This is the first vertex, and this is, I'm talking about a triangle formed with y-axis. This is second and this is third vertex, right? Now, if you are asked to shade the triangle formed by these two lines and the y-axis, yes, your triangle stops here. This is your triangle. If you are asked to shade a triangle formed by these two lines and x-axis, this is your first vertex, this is your second vertex. Wherever this line touches x-axis, second vertex. Wherever this line touches x-axis again is your third vertex. 1, 2, 3. Okay. Here, this is with y-axis, this marking. Now, if you see this is another triangle formed by these two lines with y-axis. Sometimes you will be asked to shade the triangle formed and then find the vertices, coordinates of the vertices so formed. Okay, do you understand? See, I am taking this part also. I am taking this. Just cover the area which fall within these three lines. So, this is a triangle formed by these two lines with y-axis. This is a triangle formed by these two lines with x-axis. See, this line is touching y-axis here. That will be one vertex. This line is touching y-axis here. This will be another vertex. So, what you should do? If you are asked to find with y-axis, you will take vertices formed by intersection points. With y-axis on the y-axis, x-axis on the x-axis. Okay? Yes. And here, you are asked to find vertices. What is this vertex now? X is equal to 3. Sorry, x is equal to 2. Y is equal to 3. See, now here, how do we write the coordinates from this point? Draw perpendicular to y-axis. It touches 3 here. So, this is your x-axis, x value. This is 3. Right? And what is it? This is 2. And then 3. Here. Right? 2, 3. And what is this point here now? -1, 0. Since the point is on x-axis, y value should be 0. This is, if you are asked to mark this vertex, write it as -1, 0. This is 3, 0. And what about this? This is 0, 1. Because point on y-axis, x value will be 0. Point on x-axis, y value will be 0. This is, what is the value of this now? 0, 6. 0, 6. These are the vertices. Depending on the question, you can answer. Yeah. When you are asked to solve word problems in this pair of linear equations in two variables, the first aim is to get two equations. Our job is first to get two equations and then solve using different methods. We have three methods to solve them algebraically, right? One is elimination method, substitution method, and cross multiplication method. And when you are asked to solve graphically, means you are supposed to plot it on the graph like how I showed you in the previous session. Now, this is a problem which is there in the textbook. With the help of that only, I will explain to you how to solve. Aftab tells his daughter, 7 years ago, I was 7 times as old as you were then. That means back then. Also, 3 years from now, I shall be 3 times as old as you will be. 3 years from now. And that means after 3 years. We have to find their present ages. That's how the question will be normally. Find their present ages. Now, out of this situation, we have to get two equations. Whenever there is a problem related to ages like this, use this method, which is going to be very easy. First, make 3 columns. Okay. This is present age. Present ages of both. Okay. And then dash years before. And then whether you use it or not, have 3 columns compulsorily. Dash years later, or sometimes there will be hence, after. These kind of words will be used. 3 years later, after 3 years, 3 years hence, later. That means all mean the same, after. And then the next is, we have to assume x and y here. Okay. Now what should be our x? Whichever is dependent. First you need to understand the two variables. One is dependent on the other. Okay. Now Aftab tells his daughter, 7 years ago I was 7 times as old as you were then. Okay. Here Aftab is 7 times. So who is depending on whose age now? If daughter was 7 years, Aftab would be 49 years. 7 times. If daughter was x, he would be 7 times x. Right? So who is the dependent? Which is a dependent variable here now? Aftab's age is dependent variable. Because his age depends on whatever the daughter's age comes. So daughter's age is independent variable. So let's begin with assuming daughter's age. Let the daughter's age be x. When present age we are talking. Okay, present age. I was 7 times as old as you were then means 7 years ago. So our column here in this blank, what do we get? 7 years ago. Okay. Then here, let the daughter's age be x. Let Aftab's age be y. Simple. Okay. Daughter's age x, Aftab's age y. Very simple. 7 years ago, what would they be? 7 years ago. For example, if you are 15 years now, what was your age 7 years ago? 15 minus 7. Right? If you are 16 years now, what would be your age? What was your age 7 years ago? 16 minus 7. If your age is x now, what was your age 7 years ago? X minus 7. Right? Whatever is the present age, minus 7. Forget about the algebra. Simple logic. Right? Now, daughter's age is x. So, what was her age 7 years ago? Daughter's age, I just write in short form. X minus 7 years. What was Aftab's age? Y minus 7. Aftab's age. Y minus 7. Fine. Very good. Next, we will finish off the relationship here first. Aftab says, that means you write in words. Very, very important step this is. Aftab's age was 7 times. I'm writing everything. Whatever was 7 years ago story, I'm writing under 7 years ago column only. Okay? Before. Because this entire relationship, the first statement is of past. Aftab's age was 7 times daughter's age. See, very easy to change it to equation. Aftab's age, I'm talking about this one. Aftab's age, y minus 7. He was equals, especially in algebra, was, is, everything is equal to 1. Okay? Was means put equal sign there. 7 times. What is daughter's age? We have written here in this column. X minus 7. Right? Okay. See, Aftab's age, which we know is y minus 7, was 7 times his daughter's age. Now simplify this, you will get one equation. Quickly I will do 7x minus 7. Right? Now here what happens? 7x minus 49. Yes, transpose everything to one side and make an equation. Okay. Minus 7x plus 49 plus y minus, okay, this may be confusing. First I will write whatever is there on left hand side. Bring this term by term. Plus 7x will become minus 7x. Minus 49 will become plus 49 equals 0. So what is this now? Minus 7x. This is plus y. This is plus 40 equal 0. Yes. If you are not comfortable with negative sign for the first term, you can change this as plus, but when you change this as plus, whatever is the other side, you should change it to the other. If you are making this plus, you can rewrite this as plus 7x, make this minus y, make this minus 42. This is what? Equation 1. One equation is ready. Now, let's move on to the second part of the information given, which we have not used still. Because we are supposed to get one more equation and we have not used the second part of the statement given. We will get out of that. 3 years from now. So, what is this blank to be filled with? 3. Okay. 3 years from now. First, let us get this kind of general form first. Let the daughter's age be x. Present age is x. So, what will be her age after 3 years? X plus 3. Right? Because if you are 15 years now, your age after 3 years would be 15 plus 3. 16 plus 3. X plus 3. So, daughter's age, x plus 3. Similarly, Aftab's age, y plus 3. Now, we will apply the condition given here. 3 years from now, I shall be 3 times as old as you will be. So, what did I say? Here, you should first write in simple words. Okay? I means it is Aftab is telling. So, it is Aftab will be. Aftab will be. Aftab will be, what is it? 3 times. 3 times as old as daughter. As old as daughter. So, what do we write? Aftab's age. What is Aftab's age here? Y plus 3. Will be is also equals in mathematics. Is, was, will be, everything is equals only. 3 times. What is daughter's age? X plus 3. See? Simplify. You should get your equation 2. Transpose 1 by 1 plus 3x will become minus 3x plus 9 will become minus 9. So what will it be? Minus 3x. This is plus y plus 3 minus 9 minus 6 equals 0. Rewrite so that you know the first term is positive. 3x minus will become plus, minus y minus will become plus 6. What is this, children, now? Your equation 2. Equation 1, equation 2. Did you observe this? Here, you just have to replace. There are 3 parts whose age equals the other person's age. Okay? This is how we change the given situation into equation first and then tools. Now with the same equations, I will show you how to solve them algebraically one by one using all the 3 methods. To solve this pair of equations using 3 algebraic methods one by one. Now first, I will show how to use elimination method. Elimination method. As the name itself suggests, in this we eliminate one variable so that the equation becomes one variable equation and you can solve the value, you can find the value of that variable and then we can put it back and find the other value. So our aim is to eliminate one variable. So let's take the equations. 7x minus y minus 42 equals 0. Then 3x. So now what we have to do here is plus 6 equals 0. Here we have to either we can eliminate x or we can eliminate y. You should see whichever is easier for you. You have to, if you are eliminating x, what you have to do is mark the coefficient of this, and what we do is bracket the entire equation, multiply both the equations, multiply this by this coefficient and multiply this equation by this coefficient, which becomes 7. Okay? Fine. And then we rewrite the equation. As I told you, we can eliminate either x or y, whichever is easier. In this case, if you observe, y, to eliminate y is easier for us because it is 1 which is already there. What we have to do is just, this is equation 1 and this is equation 2. Here what we do is, we have to subtract equation 2 from equation 1. So you say subtract equation 2 from equation 1. So what do we get? 7x minus y minus 42 equals 0. 3x minus y plus 6 equals 0. And here when you subtract, the sign changes. Here it is plus. So plus 3x becomes minus 3x. Plus y minus y becomes plus y. Plus 6 becomes minus 6. So now you are going to read this equation as minus 3x. 7x minus 3x is 4x. Minus y plus y cancel. Minus 42 minus 6, you are going to add, but you are going to write minus sign. Minus 48 equals 0. Simplify this. 4x is equal to 48. X is equal to 48 by 4, which is 12. X is equal to 12. Okay? X is equal to 12. Now, substitute the value of x in equation 1. By substituting value of x in equation 1, I am already writing it as minus 42 transpose to right hand side. 7 times what is x for us? 12. Minus 1 equals 42. So what is this? 84 minus 1 equals 42. So what do? We'll transpose this 84 minus 42 equals minus 5 will become plus 1. So 84 minus 42 is 42. Okay, right? So now to try to understand, we assume daughter's age as 12 and daughter's age as x and Aftab's age as y. And what was it? That this is the present age. Okay, 7 years back, Aftab was 7 times. So what was 7 years back? She was 12 minus 7, that is 5 years old. This is how you can check whether your answer is right or wrong. So 7 years ago, she was, I'm just showing an example how to cross verify. 7 years ago, she was 12 minus 7, which is 5. And what was he 7 years ago? 42 minus 5, which is 35. And what was the condition? Aftab's age was 7 times daughter's age. Aftab 35. 7 times daughter's age 5. See, 35 equals 35. Verify. LHS is equal to RHS. That means our answer is correct. Now, quickly I will show you how to use the second method, which is substitution method. Using the same two equations, we will see how to solve using substitution method. Substitution method, in this what we do is we express one variable in terms of the other variable. Remember that we discussed while plotting graph, while plotting the equations on Cartesian plane. So we use the same method. That is nothing but substitution method. We express one variable in terms of the other variable and we put that in the second equation. Now let this be our equation 1 and equation 2. I am taking equation 1. Take equation 1. 7x minus y minus 42 equals 0. Now let us try to substitute in terms of, we will express y in terms of x. You can express x in terms of y also, but this is just a trick that we need to adopt. You see, whichever is smaller. Now y is smaller than, the coefficient of y is smaller than x. So let us keep this on left hand side. Whichever is smaller. Minus, I am going to retain only this and transpose all the other values. This will become minus 7x. This will become plus 42. So I will rewrite the equation, changing the sign. I am making minus y as plus y, minus xy as 7x as plus 7x, minus 42. Okay, now substitute, we'll call this equation 3. Substitute equation 3 in equation 2. Now first we started off with equation 1, right? We got, now that we have to call this equation 3 because we already have equation 1 and 2. Now what? Since this is a substitution method, our substitution has to come into the picture. Substitute this new equation 3 in equation 2 because we still haven't touched it. Right? This line is very important. Substitute equation 3 in equation 2. 3x minus y plus 6 equals 0. Substitute. 3x minus, what is y for us? Here. Whenever you get a negative sign, remember to put this entire thing in the brackets. When it's a negative sign, I repeat, take this entire thing into the brackets. Plus 6 equals 0. 3x, now remove the brackets using simplification. minus 7x minus into minus plus yes 42 plus 6 equals 0. Now here 3x minus 7x minus 4x 42 plus 6 plus 48 equals 0. I am going to transpose this. 48 is equal to 4x. X is equal to 12. Do you remember? We got the same answer using elimination method also. Now, I am going to substitute this in equation 3 because it is ready for substitution. Again, you should use the word substitute. Value of x in equation 2 because it is, in equation 3, our new equation in this. Rewrite. Y is equal to 7x minus 42. What is this? 12 minus 42. 84 minus 42. Y is equal to 42. We got the same values using elimination method also. Right? X is equal to 12, Y is equal to 42. Now let's understand how to solve these equations using cross multiplication method. Before we begin that, I will show you a trick to remember cross multiplication method. Here we have to write x, y, 1. Okay. Then in the borders, now we are going to write values here, 2 values, then here. Okay. So here in the borders, we will keep the borders ready. B1, B2, B1, B2. In between these two, first we will take C1, C2, then we will take A1, A2. Cross multiplication. The name itself says cross and get a multiplication sign. Cross. Get a multiplication sign. Cross multiplication. Okay. Yes. Now we'll see how to write this. X divided by, in the same order. First, this is the first letter. Same order. B1, C2 minus. So, this is nothing but minus B2, C1. B2, C1 is equal to, next, Y. What is the beginning now? C1, A2 minus C2, A1. C2, A1 is equal to, we have 1 by A1, B2 minus A2, B1. A2, B1. Now let us see how we can use this to find our x and y. Our aim is to find the value of the variables x and y. Okay. So we are going to rewrite this as, first we will consider this ratio with this and rewrite. Okay. X by B1 C2 minus B2 C1 equals 1 by A2 A1 B2 minus A2 B1. Bring this here. X is equal to B1 C2 minus B2 C1 divided by here, which is there already. A1 B2 minus A2 B1. Similarly, we form, this is X. X is equal to, this is the formula we get. Similarly, you get y is equal to, see, if this goes to numerator here, now you will consider these two ratios. And finally we will get denominator will remain the same. This will go to the numerator. So we get a1 b2 minus a2 b1. Then this will be in the numerator c1 a2 minus c2 a1. So this is our y is equal to, this is what we are going to use for finding y value. So now keeping these two formula, we will try to find the values for these two equations. Now here, this is already in the standard form, right? a1x plus b1y plus c1 and then the other equation already in the standard form. Now what is a1? If you want, you write on this first, a1, b1, c1. What is a1 for us? a1 is equal to plus 7. Remember to use the sign plus 7. b1 is equal to, yes, nothing is there means 1. Minus 1, very very important. c1 is equal to minus 42. Right? Similarly, for the second equation, this is our first set of values. This is very very important for us. This is the first set of value. Next, second set of value. What is a1? So here, so a2 is 3, b2 is minus 1, c2 is 6 plus 6. This is our second set of values. Now we will see how we can use them in finding x value. X is equal to, what is b1? Use both the hands. This will be easier for you to find the answer. What is b1? b1 is minus 1. What is c2? Here, come here. c2 is 6. Bring the sign, minus. Then, what is b2? Minus 1. Always another tip to remember, when you get a negative integer, immediately bracket them. Put them into the brackets. Okay, coming back. b2. What is b2? Minus 1. What is c1? Here, minus 42. Then, what is a1? a1 is 7. What is b2? Minus 1. Minus a2, 3. b1, minus 1. Minus of plus, minus 6. Minus into minus plus, plus into minus, minus 42. Divided by. Plus into minus, minus 7. Minus into minus, plus 3. Minus, both the signs are same, so we are going to do addition. 48. Minus 7 plus 3 minus 4. This is nothing but 48 by 4. So this is 12. Remember, we got x is equal to 12 in the previous two methods also. Yes. Now let's find the value of y. Denominator. Now see, denominator in both these variables formula are same, right? So we can as well write this value which we got in the previous step, which is minus 4. Next, what is C1? C1 is minus 42. What is A2? A2 is 3 minus, what is C2? C2 is 6. What is A1? A1 is 7 divided by this one. Minus 126 minus 42 divided by minus 4. So this is, you have to add minus 168 by 4 minus 4. So as I told, both the numerator and denominator negative integers, so the fraction changes to positive. 4 4s are 42. So what is y value? Y is equal to 42. It's the same value we got using the other two methods also. X is equal to 12 and y is equal to 42. So remember to use it like this. Borders C and A. Write like this and you can write the equation like this. You will get this kind of formula. Yes, with this all the concepts of this particular chapter is done. You can solve the exercises. While solving the exercises, if you have any doubts, if you need further clarifications, you can use the description box for the email ID. You can send your doubts on my email ID. I will definitely clarify, and native center school students can WhatsApp me your doubts as you have been doing till now. Then I will clarify your doubts. So stay home, stay safe.